Good afternoon, Anil Garu. Good afternoon, Anil.
Sir, good afternoon, sir. Sorry.
Rajshekhar Garu, shall we start?
Yes, sir. Padmalata madam. Padmalata madam.
Sir.
Start chestar madam.
So good afternoon to one and all. Myself, L. Padmalata, working as Assistant Professor in the Department of ECE at Gudlavalleru Engineering College. It's my immense pleasure to introduce the speaker of this session, Engineer Anil Kumar Burra. Mr. Anil Kumar completed his bachelor's in ECE and master's in embedded systems at Research Institute of Microsensors, ACTE and System, University of Bremen, Germany. He started his professional career as embedded developer for industrial camera systems. Later, he promoted to technical sales manager for key accounts in automotive sector. His work profile involves supporting customers in architectural level of integrating SerDes devices. With this brief introduction, I would like to welcome Engineer Anil Kumar Burra to start his talk on IoT trends in automotive industry.
Anil Kumar Garu.
Welcome, Mr. Anil Kumar.
Thank you very much, madam. Thank you very much, sir. If I may share the screen. Sorry. Right. So you see the screen now?
Yes, sir.
So does it show IoT in automotive industry?
Yes, sir. IoT in automotive industry.
So perfect. So
it is not showing in slide mode.
Really? Okay.
Slide shows.
Slide mode.
Okay. Enough?
Yes, sir.
Yes.
Right. Okay. I was actually working on parallel screen. So anyways, thank you very much, ma'am, for the kind introduction. Thank you very much, sir, for giving me the opportunity to share my ideas and my experience in automotive industry. As madam introduced me, I'm currently working as technical sales manager for automotive industry for key accounts. And in my workstations or work structure, I come across more often than not requirements on IoT and serializer, deserializer memories. So I am here to share my experience on how things are panning out in automotive industry and what is the market requirement and how, as electronic engineers, we need to find a optimal solution for all the existing problems, so to say. I just want to make this session as interactive as possible. So after finishing the presentation, we can share some ideas. If you have any questions on how the market applications are going on and how the OEMs are thinking about the technology, feel free to ask me any questions, and we will try to make as interactive as possible. It is not just like one-way traffic. And knowing the fact that I'm the person between you going home and now, I just don't want to take much of your time. So without any due delay, I would like to start the presentation. Today's agenda, I'm trying to focus on how the trends of automotive industry are and how it's being developed. And with the development in various sectors of automotive industry, how we have plenty of challenges being kept in IoT sector, so to say, as well as in serializers and memory sectors and whatnot, which is involved in a current day car right now. And also briefly touch on the need for interior lightings in automotive and how do we need to have a secure hardware for that. So basically, we are so conventionally made, having an idea of how the car used to be. If someone has asked us what is a car, what was a car, for example, for instance, in 1960s or 1950s, it is as simple as bringing us from point A to point B. That's it. You don't need to do anything. You don't need to do much of things then and there. It used to have a limited hardware, only mechanical things used to run it, and it is a means of transport, period. We used not to have anything other than this in a car. So we were actually very happy to the fact that we can go from one point to another point without any big hurdles and in a very faster pace. That was the very intention of the car when it was invented for us. And not to mention that it is one of the more secure compared to a two-wheeler, for example. But things actually started to change in a way a particular audience look into a car. As a customer, as a consumer of this product, we just wanted to have many things starting to embed in a car, like, oh, what if I have a phone and I want to talk phone, or can I charge it? Is my car able to play audio? It used to have this invention of tape recorders inside the car itself. And thereon the power which is supplied to these kind of devices which are embedded by the car actually grew, and we were pretty much happy with that. And then came seat belts, and then came so to say all sophistications. Then on there on everything added on top of one another, and the whole definition of car has completely changed. It is no more a means of transport which takes from point A to point B, but this is a car right now. So you do have all sophisticated things, like you can video conference in your call. If you want to watch a movie of Netflix, for example, so to say, with HDCP compatibility, it is possible. Even you have you used not to have displays. Everything used to be analog meters previously, and you used to have only side mirrors, for example. Nowadays, everything is changed with the kind of technology is ruling in. You have air conditioners in the car, which are human machine interfaced. So it detects the temperature of your body. It automatically sets the temperature. You can do every possible bit and map. So it is basically a second house for us. So once you are stepping out of your home and going into the car, it is just like a second home to us. It is not just taking from point A to point B, but you can do everything. I can attend a call. I can practically video conference in the call. I have a self-driving mode. I have a mirror or a head-up display which shows the camera inputs on the windscreen itself. So everything is on an advanced pace. So what this essentially means, so it's not just the ideology of the common consumer that changed. It is also how we as engineers has thought of data processing. So it is quite simple. When you have analog devices, or when for example, take speedometer, it used to be analog. It just used to observe the torque of the wheel, and then it used to have a particular speed, and it used to toggle the needle in such a way that it indicates what speed you are going in. Now you have a digital meter for that. So every bit of information is being transformed into another format when it is being subjected on a display. And if you have a mobile phone, you don't for us to play a song, for example, you have a Wi-Fi hotspot in a car. So it is a connection between your mobile phone and any kind of peripheral in your car, so that it speaks. So it's a both-way communication. You can practically speak to your car now. So that means for an engineer like us, the amount of data that the car is accessing from us has gradually exploded. So on a daily basis, if you're using your car with half potential and you are traveling for a kilometer or a mile, for example, you could possibly use 60 to 70 megabytes on a half paced. So that is the kind of data processing or the memory that is required if you are driving just for a 1 mile with using half potential. It is for one car. What if, how many, I mean, tentatively there are billions and billions of cars on road at this particular moment. And if every car is trying to access the same amount of data from the same from a user, for example, and more often than not, you are not the only user that is using the car. You might be traveling with 3 to 4 people, and everybody is using a phone, and everybody is wanting to watch a different video. So every kind of sophistication in the car, in the advancements of an automotive industry, led us to have a higher data rate. So it is with the kind of emphasis that we are getting as a second home, not an automotive or a simple 4-wheeler anymore. You as an engineer need to deal with a lot of data. And there comes the point where you need to parallelly process different elements at the same time. So you might be sitting in a car, for example, and you are reaching home in half an hour, and you just want to switch on your rice cooker so that the food is warm by the time you reach home. How could you do that? You can actually trigger your microwave or your rice cooker or electric cooker, which is smartly functioning from your car itself, from your mobile phone itself. So everything is now smart. Nothing except for the human being, everything is smart. On the contrary, human being has a little less smartness compared to all the devices that he himself is creating, so to say. So you have different elements, different subjects. You have a workplace, you have a home, you have a car, and you have different elements. You can practically trigger your work computer whilst you are home. So you are parallelly processing every bit of application or every appliance that you have got from practically anywhere in this world. So what this basically is doing is it is opening a channel for us, so that the interfacing between 2 to 3 elements is becoming on the same platform. So it used to be in a case where with the smart functionality, the interfaces would be basically different. For a rice cooker, probably the interface is different from compared to that of a mobile phone, compared to that of a signal. So now with the intelligent systems that we are building, everything is communicating with everything, and which is making on one side the life of the user very simpler, and on the other side the life of an engineer very complex. Because just imagine if you as a node, in a normal automotive sense or an industrial sense, you call every point where you're getting the signal from as a node. So if as a node you are getting multiple signals at a single period of time, you can't do parallel processing. You need to have time division multiple access to get the information, to process the information, and either to save it or to display it. So as the number of devices that is trying to target a node increases, or the amount of data that is coming from the device is increasing, the amount of time the node is taking to process that information is also increasing. So what this actually is an alarming signal, because practically everything is communicating with everything. So that actually goes into managing the data. I will cover about the managing the data after actually giving a short introduction of how the trends of automotive is going right now. In the trends of auto, in the commercial business of automotive, now there is a huge rise in autonomous driving and electrical vehicling and no diesel trend. No, for a major part of it, no diesel trend is as close to electrical vehicle. Pardon my typo here, it's TREND. Is electrical vehicling is as near to no diesel, but it's not the same. And autonomous driving is altogether a different ball game, where you don't need a driver, you don't need to control a vehicle controls itself. And the basic question that comes from vehicle controlling itself, and the kind of data that we are speaking about, because everything is speaking to everything else, how we can manage these two elements at the same time. So with autonomous driving, you need to have artificial intelligence units where you train, for example, if a car is coming at a particular speed, like 50 miles per hour, 50 kilometers per hour, to the left of your side and to the left side of yours, and there is already a truck which is on the right side, what is your next step as a driver? So it is just transforming our human ideology of logic into what's coming up, what it needs to be done. So for that, you need an information not just from your car, just like my car is going at like 40 miles per hour. It is also the information that the truck which is on your right side is going at like 20 or 30 miles per hour, and which is the car which is coming from the left side of yours, which is trying to overtake you, is going at 70 miles per hour. So for this machine to make an intelligent analysis of what needs to be done next, it has to have the mathematical probability and calculations from every possible angle. So it needs to take into consideration the speeds of both the vehicles, the lanes in which they are going, and is there a signal which is coming up? Is there a car which is in front of our own vehicle to make a decision? So this node, one of the nodes in our car will access all this kind of information. So it needs to make a smart decision in less than 330 milliseconds, which is a technological norm for ISO 26262 for us. So in the whole scenario, how it can be done. So it is actually on the third phase of autonomous driving right now, where it is half autonomous and half manual. Still the decision making of switching the lanes or anything is currently on the current day, which is not official yet, is still being done by the user. But there will be a phase which is coming in like 7 to 8 years where you don't need technically a driver anymore. So how does a machine does all these things? It's just by analyzing the data and analyzing the use case scenarios. So we train a machine with the use case scenario. For that, you need a data from our own car, as I mentioned, from all the different nodes, from a signal which is in front of us. Is it turning green? In how much time it's going to turn green? As a user on nowadays, we can just say whether the signal is red or green, the traffic signal. But in a smart environment, in how much the user also already knows, or the car already knows, in how much time it's going to be green anymore. So it's so I can technically train my system saying that in 40 seconds, the light will be green. So you can start your engine after 30 seconds, let it warm up for 5 seconds, and then you can, after 5 seconds, you can go into the gear number 1 and gear number 2, and so on and so forth. The whole training mechanism, how we are training it, is getting information from many other sources. So which basically turns into the typical Internet of Things for automotive. That is how we as electronic engineers are having challenges in automotive industry with just autonomous driving. It's not just with autonomous driving. On a day-to-day normal basis, we are using Internet of Things to lock your house from your car, or just on a screen. To be honest, in the car there are nowadays functions where with the car, where you paired your mobile phone, you can do everything technically possible that you need to do at home after you reach home from work, for example. So what does that mean? What is with the trends which are going on? What does it actually mean? That means that we are having more and more and more of data which is flying in from different sources. Okay, wait, we have a lot of data. Then what we do with it? We need to process it, right? Because if you are having an uninterrupted video signal which is coming from a rear view camera that displays your parking or whatnot, it is. If it is a high resolution with a bandwidth of maybe, I don't know, 3 gigabits per second, is your machine good enough to handle that is your SoC or system on chip or your head unit is good enough to handle this kind of specifications? If not, we need to compress it. Okay, then comes a point, which compression technology is best, or which is better for the particular circumstance? So we can't take the data and project the data in the same way, but we need to process the information. So which gives a lot of scope for embedded developers like us, or who wants to process the information with signal and image processing from the point the source collects the information to the point it is displayed on the screen. So there is a huge scope for us to better the system, to ease the so to say the communication protocols. And then what we do if we are not displaying it on a display, for example. So there is a camera input that is coming, and I'll give a classic example of there, for example, God forbid, there is a car crash. So in the car crash, one needs to analyze what happened. And this car happened to have a video camera that collects the data, or that video framed every frame of the data that's going on. It actually is stored before it is being displayed on for any sourcing purposes. So just imagine if there is only one camera, and if you're using H254 or 264 or 265, for example, the amount of data that is collected per a minute, if your bandwidth is say around like 1.5 gigabits per second, you need to have a storage unit of around 7 gigabytes of memory, something like that. So this is how, only if you're using one camera. But the automotive sector nowadays are having around 16 cameras that are actually viewing 360 degrees view, and you are having in the times which I'm going to mention it in the later part of my presentation, where you actually have no side mirrors anymore. So you have a side mirror. You used to have a side mirror where you can view what's coming on from the rear sides of it. So even from the center rear camera mirror. So now everything is changed. Everything is camera input. So you have a video display which is coming and which is buffering and binning all the videos coming from each side of the car. So you don't have a mirror anymore. So you need to store the amount of data that the cameras are taking as well. So this actually is a very tricky situation for us, because more the amount of data coming, the more the storage is. And it actually needed a lot of investigations on what is the memory technology that is best suitable for automotive grade. The automotive grade is of three types: grade 1, grade 2, grade 3, and most of the times we are using in grade 3 mode, which is 40 degrees minus to 105 degrees plus. So in between this, how long your memory is going to store the device, and how you can retain the information. So every bit of it is a complicated thing for developers like us. So we need to concentrate on bettering our technology and bettering our solution process. And the most important thing for IoT, which is a biggest bothering point at this particular technological trend, is security. So it is as simple as that. If you are having more number of sources talking to a node or communicating with a node, if I can crack one node, I can probably crack all the sources that is providing me the information. So my information needs to be stable and more secure. So for that, it is the most hard, or the most difficult thing that's in the research and development going on nowadays since the rise of IoT is securing the information. How you can secure the information? It should not be paranoid. The only processing of the information that you do is from yourself, not from anybody else, and you do not want to encourage any third party. So there is a different dynamic here. For example, if you are a person who is providing a serializer, deserializer product to an automotive industry, and someone else is providing a memory device, But essentially, both of these two individual sectors are communicating with the same node, and the interfaces with which both the devices are communicating with the memory is different. You need to have a standard platform where the communication protocol is established, and it has to be more secure connection, so to say. So how as a tier 1 who is doing the security protocol will ask the tier 2s to work with the same interface architecture? So it is quite impossible to have a common ground when you're having 10 different suppliers for 10 different things which are being embedded into a car. So that is a basic step for any kind of development, but still we are having lots and lots of problems because of the ideological differences between different vendors, because everybody thinks their technologies or the interface that they are using is the best. So as I told, what is now that we know the amount of data that is coming into a car or access by a node is more, what does it leave an electronic engineer in this real world? So it is as simple as that. Whatever we do, if we go to the grassroots basics of electronics, we are working with data. We call data a signal, or bits and bytes, or analog pulse, VPB, or what not anything, or any kind of data that comes into the picture. So obtaining the information from different sources is like video, audio, or data, or image, for example, and process the information in a way that it goes smoother, which is by modeling or modulating, compression, image compression, or encryption. These kind of things are very much needed before you give your information out to the source. Because, for example, if you have a Netflix stream that needs to be done on a display, if it is not HDCP compliant, there is every possible way that every frame of your video can be corrupted, can be stolen out of it. And and Netflix has the proprietary right on a video, or so to say, anybody. I'm taking Netflix as an example here. So it has a proprietary right on that video. So now when the hacker can take out the video without HDCP key, it is always a problem for the source encryption itself. Either you need to be source encrypted or you need to be source coupled. So you need to either the video coming already inside the car can be HDCP encrypted, or your car can do as a HDCP repeater. But you need, for us, it is very, very the basic necessity here is to have a secure connection with this video stream that is coming in. So now after getting the information, after processing the information, you need to transmit to some other port. When you are trying to transmit and receive, you do have different formats of doing it, whether you are using wired connections or wireless connections, and you have bunch of protocols when you're doing with wires. If you're talking about speech, I2S, audio signaling, or if you're talking about video signaling like DSI, CSI, where the MIPI standards kick in, and there is a lot of development in the video interfacing with display ports and embedded display ports nowadays in the industry. So once you receive the information, how do you reprocess it? For example, if I have a compressed video which is coming at VESA standards as DSE, as a DSE compressed 3:1, for example. So just to give an overview of DSE is an automotive compression VESA technology, which is the only format that the automotive industry accepts, and ISO 26262 or PPAP will follow. And there are only 3 steps of it. Either you can do 1:1, 1:2, or 1:3 in the case like. So for example, if a video which is received is a compressed video, how can it be projected into the display? It has to be recompressed again. Whether or not it can be decompressed in a receiver or in a TCON is absolutely a different question. So for us, we as an engineers work on a problem statement. So for us to work on it, what we need to do is a standard path of communicating. And in our case, the signal which is coming in from different formats has different information content. and the processing of it makes it more difficult. In nowadays automotive, you have a screen where you have the navigation system coming up, where you have the weather information coming up, where you can play the songs, you can change the songs or the video that is playing. At the same time, you want to have the speed at which your car is going displayed. So there are multiple different information ports, the sources of information. Obviously, the information about the maps will not be provided by the same source as the information that is provided about the speedometer. So the whole infotainment system is a complex thing, and to have every possible information projected into the display, it takes a lot of precedence in processing the information. For us, it is a very, very great opportunity where you, as an engineer, you collect the information and project it. And then, as I mentioned just now, either you need to have displays or memories to reprocess or reprogram the information. So on a whole, this is the part of an electronic engineer, from the point where the source is giving the information, come what may be video, audio, or data, till the moment it is displayed on one particular destination, so to say our source and endpoint. We can play a major role in every point of it, and we have a lot of scope for new technologies coming in, and from the design point of view, for an embedded system, for a microcontroller to be smart enough to not just relying on a software encrypted program. I'm going to cover about it in the next coming slides. So this the whole information process is giving a lot of chance for engineers like us to be up to scale and do a lot of research about these things. So as going a little deeper into sensor fusion, I was just mentioning about these cameras, just about cameras. You have in a car the amount of data that is coming in. As I mentioned, it is coming from radar, long distance radars, or cameras, or ultrasound, or anything. So when you're traveling in a car, without our knowledge, as a user, without our knowledge, the car is actually doing many number of things, or it is a cumulative part where different individual tasks are being processed at the same time. It means the car has to have ears, eyes, and all the kind of sense organs that we have. So it needs to see the road, watch the road, and train itself, unlike us. So it is learning from the experience, and it need to have the amount of data collected from every source of it. It's just not the video that is coming in. It's the as I have already given an example of the information that you got already from a signal light. In 40 seconds, it's going to be green again. So your car needs to think intelligently, and for that intelligent decision making, it is taking information from many sources. And as a node collects the information, it is always, there is no, as we argue with normal audience, there is no one good way of doing things. There are n number of ways of doing things. So what is the best ideal scenario in which the car needs to think about? So these kind of decision makings are the future, and the automotive industry is going through a training phase for an autonomous driving right now, and this is basically focusing on the IoT, as the security is blinking on a lower scale at this particular point, which turns us to embedded security. So as theoretically mentioned by me, your car now can store your credit card details. I don't know if you have already used that in your car. You can pay from your car, you can pay from your watch, you can pay whatever it is. So just taking Apple as an example, you have an Apple iPhone, you have an Apple Watch, and a MacBook or iCloud. So all this data is being subjected, and if I can crack one of your passwords, I can have complete information about your payment details. I can use your, so as the technology is growing, so is the chance of your data to be corrupted also is growing. So we just want the technology to grow, but at the same time, we need to stop this attackers or hackers from outside. So the system that we are building needs to be more and more secure. So if I can hack your car on a current day basis, I can practically go to your home. I can practically buy anything from the payment methods that you saved in the car, and I can even, if I hate you, for example, I mean, just hypothetically, if I hate somebody, I can reprogram the car in a way that it automatically goes into an accident zone and hits something and somebody. So what does this mean? We actually love the advancements in the technology, but we don't like being hacked or being, being stolen from somebody. So it actually is a gray area that we are right now. So where and the same time you enjoy it, you can't enjoy it on the full face. So this actually rose to a bigger deal of cyber security, embedded security that the microcontroller units are building on. So why is this happening? Why is this this happening a lot? This is happening because the number of cars that on the road or which are connected to each other rose from one point to another point. In 2015, when the whole autonomous driving technology or the thought process kicked in, there were only few millions of cars which are connected to each other. So which are like hardware connected and not in contact with each other. They were just used to provide us the information about it, but they used not to talk in between themselves. But now with the technology growth in 2020, you almost have 152 million connected cars, which not just communicate between a user and the car or the infrastructure in the car, but to the car and everything. So we call it in automotive terms V2X. So your car can talk with practically anything, like it can talk to you. It can talk to another vehicle, it can talk to a signal, it can talk to a payment method. So it can even talk to the satellite. So this is a scary part. This is, of course, as good as excitement it brings the same amount of scareness in us as well. So it is as scary as it is exciting for a technology on this running pace. So is it just affecting the car manufacturer OEMs, or is it the whole ecosystem it is doing? For the major part of it, it is not just the car manufacturer OEMs that they are dealing with. It is actually dealing with the whole OEMs, where different suppliers or tier ones will be providing different informations about serializers, about the infotainment system, about the navigation, and so on and so forth. So the whole ecosystem in which the cables and connectors, where Leomi or the connectors in which the information flow is based on, every part of it is being affected. If I can say about the communication, it's third-party suppliers to, for example, Garmin, which supplies the maps, Netflix, which supplies the video content, or Comcast, which actually does the direct streaming of the televisions into the machine. So it's not just one point. We say that, okay, there is only problem at this particular point, and we do not have any problem at any other subsystem. But we do have individual problems as a cumulative that we need to answer. So it is affecting the whole ecosystem of it. Sir, something is popping up upstairs with chart in 5. Do I need to stop for a bit and address those, or Kamara sir? Kamara sir? So thank you. I think it's so if you have any questions meanwhile, sorry that for the stop. If you have any questions meanwhile, just drop me the message, and in the interactive session we can just talk with about these questions. So as engineers, we have a common, as I told, we need to have a problem statement, and we actually work on the problem statement in a way to solve it. So one of those segments that are affected by this this Internet of Things is fleet management. Fleet management is in a normal easier way, it is a courier service. For example, if you take a DHL or a post truck that is coming up, so or a machine which delivers some raw materials from point A to point B. By the time there are possibilities, by the time the goods are put into the machine on point A, where the supplier is the one, and it goes to the customer, by the time the goods are loaded, they might be damaged. You never know. And while after loading, the truck starts, and there might be multiple stops. He might be overspeeding. There might be police who stop that vehicle, and or he might be stopping for food or something. No one actually knows what happens between point A to point B. No one actually not used to know it. But nowadays, with this IoT, Internet of Things, every particular data, every particular step of it is being recorded. So to say that by the time the goods are being loaded, you can have a technical photograph of the goods that are being taken and loaded to the server. And then when someone stops you, a policeman or anybody stops you, or there is a traffic for like 2.5 kilometers, you can have this traffic information loaded into it. So every bit of information that is coming into your car is being recorded now. So what makes it a easier process for a supplier when he's going to deliver it to the customer? That there is a possibility that customer might say, oh, it is delayed and I just don't want to use this product anymore because it could be spoiled or something like that. So there is always a possibility of reasoning. So you as a carrier supplier, fleet management, you have this possibility enough to have the track of every stop that you had made, or every good that is being inputted into your truck before you started. So at this, it is for better transparency. It is for making the things easier for people on normal usage way. Just on a common thought, how we used to travel from point A to point B without navigations. It used to be very easy. We used to open the hard-coded maps. Once I moved to Germany, there were days where I still used to use a map to navigate myself to one point to another point. Now, later came to a part where I can just put the address of the destination and I press enter. It shows me the map already. And now the technology actually has changed. So if actually the navigation machine has become so intelligent and interactive. Once you put the address of a destination, it shows 3 to 4 different ways where you can reach it, depending on it is sorted depending on the fastest route or the shortest route. And you as a user, you can choose whatever it is. And once you already decided a route to go to that particular point, and if an accident happened, it actually knows the information before you actually reach there. In 3 kilometers, if already before an hour or half an hour there was an accident and there is a traffic, you actually get a message and you say, hey, traffic alert, there is an accident, and we suggest to take this route for easier traffic. So how these kind of things are happening? Because it is tracking our car. Your car is being tracked every single way, and it exactly you might not know where you are, but the server knows where you are. Definitely, most definitely, you can trust on me. So it says, okay, it tracks every movement of you, and it says your destination is here, and probably this is the right way to go to you. Fine. When it is given by server, it is perfectly all right. But what if a hacker comes into picture and you deserve to be the most productive guy in your company, and he just wants to rob you, for example. If a car comes into picture, hey, there is a traffic information and there is a traffic, you can take this route, and he reroutes us to any place where he can rob us. It is a classic Indian movie story. So, but it is real. It is basically the reality, where if you are not secured enough in which the data is being processed, there is every possibility of us to use it in a negative sense. And more often than not, with the updating technology. Before it is being used for positive purposes, it is used for negative purposes. So as engineers, as embedded developers, when the IoT is coming into picture, when nodes are picking with every possible source, it is our duty and it is our responsibility to make it more secure transmission. How will you ensure it? Whether you would do it with encryption algorithms, or the better part which Infineon can proudly say, the technology with Infineon is they are building intelligent microcontrollers. So this kind of encrypted mechanism is being in the hardware itself nowadays, and they actually are very proud. They work along with Cypress to do this kind of microcontrollers, and it leaves very little scope for any kind of malfunction or any kind of hacking that's being done on the microcontroller itself. So it gives us a lot of opportunity to explore different areas of how we can secure the data or obtain the data or do it. My intention or the day-to-day work that I'm doing is, I will be, when I talk to a customer or when I talk to an OEM about their next architecture, it will be overwhelming to listen. Oh, is that the kind of technology that we did not miss, or we can't even imagine how deep they are thinking about and how secure they are thinking about. And every bit of a flow chart is very important for the decision making for them. It's not just anything. So in vehicle, this is one of the other elements that we can go deep into in vehicle infotainment and telematics. As I mentioned, you have entertainment that is coming into your system. You have information that is coming into your system. Infotainment is the combination of information and entertainment. So you do have the weather information coming up, saying that when you step into the car, it says like, hey, come in, with an audio signal coming in. Or if you save your car name in your car, it say like, hi Anil, come into the car, good morning, how are you doing? So everything is interactive nowadays. It is not just one-way traffic. It is not just you tell the car what to do. The car actually suggests what you do, and we need to be scared about that. It should not be a place where the car dictates you what to do. It can suggest you what to do it, and at the end of the day, you need to be the person who needs to take the decisions. So till that particular point, it is fine. So with the kind of information that is coming in, and previously in the cars, if you observe, you used to have knobs. If you want to on the air conditioner, if you want to on the heater, for example, in the car, you need to turn it with manually with your with the knobs. If you want to increase the volume, you used to manually. Now on the fingertip, you can do everything. Even customers are getting bored on clicking it. There is one of the architectures that are coming with one of the biggest OEMs. I can't unfortunately say the name of it, where if you can just swipe in the air, just if you can slide your hand, it automatically increases the volume, it automatically decreases the volume. So for a consumer application, it should be fine. For we see it on our mobile phones, where if you just put like this, the screenshot is already taken. So for a consumer application, it is good, because the amount of danger on a consumer application is less. But with an automotive application, every gesture of you is being given a particular meaning or particular statement. We need to be very careful, because accidentally you might do this and the volume might be up, or if this actually means to increase the volume. So what if your statement is if you do that, the steering steers automatically right? So it is a scary path. So once you are describing a subroutine in an automotive, you need to be very much careful, because this is what IoT for automotive is all about. It actually senses your hand, senses your movement, and then process the information and give it to it. So every bit of the communication has to be robust, starting from scanning your hand and tracing the movement. If you're doing it, it should not take it the other way around from the moving it, and the message has to be correctly delivered, and the correct subroutine has to be implemented. for that to achieve. So every bit of the technological advancements are, as I told, as exciting as it is on the same time very scary. So for us, it leaves a great room for development as engineers to bring on our ideas to make it more secure. So as I mentioned previously, automotive maintenance system. So with the mobile, you can switch on your car. With the mobile, you can open the engine itself. So you don't need to at minus 20 degrees centigrade in the cold weather, you don't need to get down and take the bumper off to heat your electronics, or if to kickstart, if for some reason your car is not working, to kickstart it, you don't need to do anything. You can just access it from your mobile itself. So what if the mobile lands in a different user's hand, and what if he's trying to do all kind of these things from your mobile unnoticingly? So for this reason, they actually have a master key password or master key, so to say, in the OEMs they are applying. It's not just important, or it's not just enough to have this mobile phone to control your device or car, but you need to have this two-layer verification process that needs to go on. So you do have a subroutine system with a local password and a global password for your car. Only if both are matching, then probably you can do anything. You could be lucky as a hacker that you can hack both the codes, but that is the reason why we need to have more sophisticated encryption algorithms like AES or hash technology, which hash should come more into picture with 128 or 256-bit programming, where it is more and more secure. So these kind of algorithm has to be preserved, and which has to be masterminded. And the whole problem lies here, because the software will be developed by a different company compared to a hardware, and both are being combinedly used in a tier one, where it builds a subroutine or subsystem that goes into an OEM. So OEM itself is a car. It's a manufacturer of the car, and there are different subunits like head unit or steering wheels or whatnot, or seats or something. So it is a collaboration of different tier ones. And for tier one, a supplier company would do the hardware design, the chip design for the whole PCB design, and other company might do the software. So whilst working, there should not be any conflict between these two companies, where the blame game should not switch. So so we as engineers need to be very robust in obtaining a common platform, where for the OEM or for a consumer at the end of the day, has to be a safer path of going from one point to another point. For example, if you are going in a place where you are using a navigation, and for example, if you chose the maps in Germany, and suddenly the map toggles and shows the maps in Netherlands, for example. So you don't know, you're middle of nowhere, and there is every possibility of a car crash in this picture. So the data manipulation is the most important thing that one needs to be taken care of, and it always falls on the hand-to-hand cooperation of software versus hardware. So for us, we need to, as engineers, when you are going into a problem statement, where lies the problem and what's the solution pattern, one needs to really understand what could be done from my side to restrict the amount of damage, or to the ideal case scenario to stop the amount of damage. Previously, I mentioned the amount of cars that in 2020 are 152 million cars on road, which are speaking to one another. Or best case scenario, V2V is vehicle to vehicle. V2 infrastructure is if someone calls you and say, hey, where are you? Are you en route? You can say, okay, I'm beside me, I have a building which says Google or something. So that used to be the case. Now the vehicle says, where exactly are you? Which point are you at? So that is it is every building of on the which is any metropolitan city has a node. that is communicating the actual location of you. So for example, this is a classic example. If you we have done it n number of times. If something happened, our car stopped, we will call our friends like, hey, can you come and pick me up, or can you do something like this. We would say like, hey, he will ask us, where are you? I said like, okay, before me there is a big building which is blue color or something. So we need to have a different address pattern so someone would identify us. But now you can ask your car, where are we, and it actually mentions the location of it. We can also do it by the mobile phone with the coordinates and so on and so forth. You can just send the phone. What if you don't have a phone? What if your car is communicating with other car, and if you don't have a phone and your car, your so-called rescue person is another car, and there is a possibility of these two cars speaking with each other. So this is the most sophisticated technology that we are currently using. So you can talk to vehicle, you can talk to a building saying that, hey, it is just like a ping signal, ping 192.26, whatever it is. So you just ping it and you get a response of where we are. So you can access a node of it. And vehicle to pedestrians. What is vehicle to pedestrians? Pedestrians are the kind of devices that they are handling also has a node, and you can actually, as a vehicle, can actually speak to this to pedestrian or the device, electronic device in his hands. And vehicle to network, this is when you say about network, it could be cloud, it could be a tower, it could be possibly anything. So it is a source where, or the destination where all the data that is coming from the vehicle or to the vehicle is being accessed through. So everything here is going through a network, through a communication. So it's not just a vehicle to vehicle, it is vehicle to a network and network to vehicle, and it vice versa. So now the trend of it is a combination of everything. It is called V2X, which is like vehicle to everything. So vehicle to it covers every part of it. So in the future, in 10 years down the line or 15 years down the line, there is every possibility of us speaking with somebody in a car in a very far location, so that you feel like they are here. So I was in a technical trade show recently, and there was an illustration of someone sitting in who is in Las Vegas. They actually could do this video conference in a way that they are sitting on the backside of your car. So it means that so for example, if someone is in the backside of your car and you're looking into the rear view mirror, you could actually see that someone is behind you, right? So the streaming of him in the in a different location could be done on your rear view mirror. So the technology is growing rapidly. The technology, the very purpose of why we are doing it might have found a different meaning, but nevertheless, it is a wonderful technology that's going around, and it is our pleasure to experience and witness all these kind of technological upgrades, and which of course is the scary part, leaves us with a lot of room for development and research. As in the whole presentation I was mentioning, for critical features, what if you can boil down the critical features that need to be delivered in IoT or connected cars, is the security of it, and the manageability of the device itself, and reliable communication. The communication is always good, but only if it is right. The communication is always bad if it is wrong. So a right way and secured way and reliable way of communication is what is the need of the hour. So it's not just talking to the car which is beside me, which is not in the same state as me. I have to talk to a car which is far away in the different continent or different location or a different time frame or time zone, anything. So this is slowly getting possible, but with a lot of risks involved. So it is a step-by-step development that we are seeing in automobile world, but in automotive industry that is kicking in slowly. That leaves us to up until this point, we just spoke about how a car itself is speaking to everything around it. What if we are sitting inside the car and talking to the car, how we are using it? Previously, we used to have this auxiliary cables, aux cables for audio connections, and you can charge the phone. But with the technological upgrades in smartphone business as well, you have only one port, and the future cars would now, for future mobile phones would also not have these cables, which would be wireless in future. But on this current day, what is the most commonly used interface to communicate with the car is USB-C alternate mode. USB-C, it is same for Android or iOS or anything. You can practically connect a mobile phone with which is having the features to stream parallelly in different screens. So you have in rear seats or behind you, if you have taken a combi car with 5-seater, you do have a rear seat entertainment unit in the center where you have the screens on it, and you have rear seat charging points, and you have a main display like CID or cluster and moving in this direction. So how can you, so if 4 people are connecting or in the car using their mobile phones and connecting them to the ports, how they are using it and how they can display a different video in a left screen compared to a right screen. How is it possible? How the splitting of this serialized and deserialized stuff is going on? And what if the amount of displays which are being used in the car are more? It will be crazy to know that that the automotive industry or the biggest OEMs who are playing the main A game are looking for a 24-inch screen in their cars. 24-inch screen. It's just where you have the information of infotainment and something like that. But it's not just one 24-inch screen. There are 3 24-inch screen coming beside each other. That means technically your car is completely a display unit. Completely a display unit. And the more the display is, the more the amount of information that need to be published. You don't want your car to be saying that, okay, this is an empty part, I just don't want anything in it. So it has to be occupied. And therefrom came the idea of stitching the skins. So what is the maximum display resolution nowadays used in a car is 6K, for example, which itself uses more than 380 megahertz for driving a signal into it. So what if we are using a 24-inch screen with a 4K resolution? So 24 times 4K, if you are having a frame rate of 60, so it multiplies. So it is a humongous screen, and you need to have a huge data that can occupy the screen size or the display size of it. This makes every bit of it, the information flow needs to be standard, the information flow needs to be reliable, and it should not have a bit flip. For example, if you have one bit flip that is occurring in any sector of it, for example, if you're having a bit flip in a navigation system, and there is a flicker in the navigation, it's not just the navigation system that is affected, but the whole system of it. Because it is having the information coming from different sources. That means if your destination is corrupted, there is every chance of it that the source gets the corrupted information as a upstream protocol. We need to be very careful when the upstream protocol is being corrupted or given. There is every chance of the host system getting corrupted. So it is not just top-down approach that you are going from. You need to also think about bottom-up approach when you're trying to do this stabilized works. So this is how the internal car connectivity is used, where the head unit here itself is SoC. And you have great SoCs coming from Samsung, Qualcomm, for example, and Infineon or Nvidia. So these kind of companies are up to date with the kind of video interfaces that they are looking for, or kind of audio interfaces that they're looking for. So at the end, they just want a comfortable. So I can actually say that a user don't want a car to go from point A to point B, but he just want a home theater in the car, so he can watch a movie and he can go to the destination at the same time. So unless until he's not driving. So so this requires huge number of data that is coming into it. So these are just classical examples of where we have the need of the hour for security in IoTs, where you have information coming into the cars from different sectors. This is a overview. This is the final overview of how the car looks like, or how, from where the information is coming from. You can work from your car. You can have this. You can even duplex your screen, or project your screen onto the rear seat unit that you are having from your laptop. So you have a parallel screen that is working on. So things are crazy going on. Things are moving on an advanced pace. If you know a car from yesterday, you don't know about the car at all. That is the reality. So in a single day, everything is changing. The display requirements, the interface requirements, the lighting requirements, everything is changing in a car. So it is a cumulative package of the latest technology that is being used. Like Bluetooth is no more in the car. Bluetooth is not the standard communication protocol with the car anymore. It is just with USB-C or anything. Even with the mobiles, when you are playing the phone, when you playing the songs from your phone, when you get in, the hotspot of the car is getting switched on, so that it's not Bluetooth anymore. It's just plugging in and playing in. So it's everything is growing on a rapid phase. So of all the things we discussed now, we actually found that there is an intense requirement for having a complete secured environment going on. How can we assure it? We technically know only two possible things. One is by a robust software. You can't crack a software solution, but more often than not, even in the Hollywood movies, they would be saying it can be hacked or cracked or anything. So for us, it is, as electronic engineers, it's a proud challenge and proud responsibility for us to have an intelligent hardware. As I mentioned previously, Infineon, working in close connections with Cypress, which is a semiconductor, both are semiconductor company, which is a microcontroller semiconductor company, are building microcontrollers which are highly intelligent. Not that they make the decision process for you, but they have this inbuilt security issues for IoT in automotive. And more often than not, the automotive companies are using for the subroutine processes these kind of microcontrollers. I advise or suggest you to go through Infineon page for that. It is very insightful experience that you'll get about this microcontroller development. With the kind of software, I'll just talk about the software later on, just to show you how the hardware security is being built. These are few microcontrollers that Infineon are using right now. These are MCUs, stand for microcontroller units. Flash, Optiga, these kind of are different, and there are different gateway applications, and everything is preferred in a different application perspective. So it is very interesting developments that are going on. I really advise you or suggest you to go through this web page for more information about how they are planning these development schedules. And regarding the software, once you have an ordinary MCU or even an intelligent MCU, it's not just enough from hardware a solution to be provided or software to be solution provided. As I told, it goes hand on hand. Even though you have a secured hardware, it's up to us to have a robust software solutions that are coming in. And just from my experience and from interacting with the OEMs or tier ones, they are more into AES standards. AES 128 or AES 256 is the most preferred solution right now. Even RSA is picking up. So we have options to play around. As I told, in the IoT, this is the biggest challenge to ensure security, because the interfaces are absolutely different, and they are trying to access a single node for all possible information flowing in from different directions. So so it is up to us to utilize these technologies and embedding with the hardware itself, with the intelligent microcontroller development, or even the powers requirements, low power VLSIs, and everything is coming into a picture, and everything is working together for a common goal. Which when the number of nodes itself is MCUs. When the nodes in a car are more, I'm just talking about one node in a car, there will be on an average of 1200 to 1300 nodes in a car, where it tracks information from different sources, and passes the information from one point to another point, and so on and so forth. So once you have MCUs, known number of MCUs, for the need of the hour is to have a microcontroller which works on a low power, ultra low power, to be fair enough. So and these ultra low power microcontrollers need to be having a proper cache memory to have this the encrypted software running in the RAM or ROM itself. So it is getting tougher, but at the same time it is getting encouragingly entertaining for us as developers. We need challenges to go through these kind of steps, and it is giving us a lot of scope for improvement. This is one of the other sectors that I mentioned in the lighting area. So having an interior light in an OEM is the latest trend. So in the next coming cars, for example, with an SOP of 2025, 2026, you do have cars which have functional lighting, ambient lighting, anything. So there are still the smart LED solutions, which actually does this human machine interface. So your LED also need to have an idea of the human machines that are or the obstacles that are going. So they will sense it, they will give the information to LED so that it produces a routine that says, like, if for example, if you're driving like this and a person is walking from left to right, it detects, the smart LED will get the information from the sensors, and the smart LED executes a routine so that there is a blue light or any light of your interest coming from left side to right side. That means that a human or any kind of obstacle is coming from left side to right side, or even from right side to left. So these are growing up more, and as I said, with the navigation information that you're getting in 2 kilometers, there is a lot of traffic. It is so embedded into the applications of LEDs now. Even it says, even on the steering, it says like traffic ahead, and be careful, something like. So we are trying to ensure the more safest way of travel for a consumer from point A to point B, not leaving any of his benefits that he's getting from a normal scale. Like, he needs to enjoy the songs, or in movies or navigation, he needs to do the video conferencing, audio conferencing, but at the same time, he needs to be safe. Unfortunately, we can't provide a technology for drunk drive people, but for anything else, we technically have to provide a solution for that. The OEMs are in a race right now, saying that who can provide more number of options in the limited architectural space that we are having, with more possible interaction sessions, like from light or sound or anything. So this is actually taking a lot of precedence, and believe me when I say that in the next 5-6 years, you're gonna have big OEMs like BMW, for example, or Daimler, who are going, or Jaguar Land Rover for the case, who are going to embed these kind of lights into our interior lighting or exterior lighting into the applications. On the other day, I had an opportunity to talk with a representative from Rolls-Royce. They are trying to have this moonlight effect on the top of their screen. So the OEM market is more going or leaning towards providing a artificial living inside an artificial car. So they want it to be as natural as possible in the artificial things that they are having. So it is so mind-boggling that I could see the moonlight effect on the top of the car. So that's something we never dreamt of. That's something we never saw it coming, but that is a reality nowadays. So you do have a lot of applications going around in for that. I just want to quickly go through, I don't want to take a lot of time about these industrial memories, but this is one of the other important, if not the most important thing that is going around for IoTs. As I told, with the number of devices that are communicating with a node in the car, it is the importance of memories has drastically grown up, that you need to save every bit of information to train your car, especially when it is coming to autonomous driving. So there are many different platforms of industrial memories. For the memories that we know, we just know hard HDD or SDD, for example. And for the same reason of endurance at automotive grade, we can't use HDDs, hard disk drives, in automotive industry. We can actually only go for SDDs or SD cards, micro SD cards, or eMMCs, UFCs, something like that. But HDD is completely out of the picture only for that reason. So your car, the amount of I don't know. I might ask you in the later parts of interactive session. What do you think is, just think about it, we can talk about it in the interactive session. What do you think is the average memory requirement in an automotive car, on a decent sized automotive car? What do you think is the average memory requirement? Just think about it, and I can share the information with you in the interactive session, or you can answer me that question. When you are dealing about the memories, there are few elements that you need to take into consideration, which is endurance, how many times you can write into the memory, how many times you can read out of the memory. That is one of the most important things, because if you can just write into memory for like 3,000 times, for example, for a 2D or 3D NAND purpose, if you are using SLC or MLC or TLC, SLC is the least where the memory can save store either 0 or 1, single logic cell, or multi logic cell, or trio logic cell. So for SLC, obviously the endurance will be higher, but even the cost will be higher, because for a user or for a developer to have the usage of 1 terabyte of memory or 500 gigabits of memory with an SLC, it requires a lot of space, as well as because only a memory cell can store either 0 or 1. But if it comes to TLC, where 3 bits can be stored in one single cell, 000 or 001, or different kind of manipulations these are, the amount of times that you can write into a device will be obviously way lesser compared to that of SLC. But on the same time, it depends on application. Is there an application where you want to write more and read less, or write once and read more? For that, so depending on the application, one can use the technology, something like that. And also at data retention with the automotive applications we are going with, and using temperatures between -40 to 85 degrees centigrade, how long you can use this this memory, how many years that you can use this memory is one of those requirements, and latency and auto refresh. So these kind of are few elements. I just don't want to go completely deep into it, but if anyone is having a question about that, I would be happy to answer in the interactive session. But I think this is one of those other things which are not related to IoT, but I just wanted to give a few points or heads up, because when you're entering into the IoT sector, this is the key element that they are asking for. So it's just a flash trend, how a 5 nanometer MLC is compared to 3 bit of per cell with ECC requirements and stuff. The most prominent uses are NAND flash, for example. For most of the parts of automotive, we will be using 2D or 3D NAND. This is a small comparison between introduction between SLC, MLC, and TLC. Where I said like 1 bit can be stored, 2 bits can be stored, or 3 bits can be stored. And as I told, for a huge requirement for every logic cell for gigabyte, you need to have approximately $4 for a TLC of around 20 cents on $20. So depending on the application, it's not like to say SLC is good or TLC is bad. depending on application, you can choose it. It's still the most preferred memory is SLC or AMLC, which is a mixture of SLC and TLC. So it is an SLC flash with the software coded with the TLC. So this is what basically is AMLC is. It's a firmware algorithm where you can set from NAND from 4 states into the 2 states mechanism like that. So it has the cost advantage versus the endurance advantage as well. Just a quite silly comparison of different memories. And yeah, endurance versus write performance, and of course with the write performance, endurance is for SLC is more. So, and data retention, if your car is stuck at 70 degrees centigrade and and the memory, how many days the memory will last, how many days the memory will last if you're working at 40 degrees centigrade or 30 degrees centigrade or minus 40 degrees centigrade. So it is a comparison where the companies will do it for a certain amount of time, and then they say like, okay, after for example 36 months or after 11 days, it is no more reliable anymore with the different projects that we have. Obviously, you can see that the data retention for TLCs are very, very, very less compared to that of MLC, just because of the fact that there are 3 bits that are stored in a single cell, and the toggling of bits is quite easier when the number of bits are more. So it's as simple as that. I think I'm almost running out of the time, so I'll skip this part with serialize and deserialize, but I will say one thing. We do have a huge impact on the automotive market from serialized and deserialized point of view, starting from fast startup to quick startup, because there are norms with ISO 26262 that once you start your car below 330 milliseconds or microseconds, your cameras should be feeding up the information into your system, or the whole process need to be initiated already. For that, if a normal startup procedure for serializer deserializer would take 2.6 seconds, so there is a need for a quick startup or fast startup procedure. For that, you need to have this FIR settings automatically auto-tuned or something like that. So in this direction. So I would be glad to have this the conversation if anybody is interested. Just to say that this was one of the problem statements where do you find a problem and how to solve it. I think I'm running out of the time, right? So yeah. So I'll just run it really quick. This is a problem statement where you find different flicker effects, and once it going into a device, and you understand where it is, and as an engineer, as a part where you have this many video interfaces coming in, or much of the data coming into it, you need to downscale to a point to easily solve a problem. It is always important not to have a robust solution, but also a quick and dirty solution. But because most of the corporate world runs on not a long term, they also run on long term problem solving, but also they want to fix the problem first, so that they will get rid of it, and then for the next product development they will be focusing on a need development as well. So it is just to eliminate the solution and just to analyze a chip, where it is happening, and so on and so forth. What is the digital code to analog core, how the flip-flops will be, which grade of flip-flops will solve it. Once you get into the system, and once you get a note of it, it will be easier for you. I'm sorry that I had to skip all these slides because of the restriction of the time that I have right now. So that's it from my side. Thank you very much. If you have any questions, we can make this interactive, and you can ask whatever question you have regarding automotive, IoT, or security, memories, something like that. Kamala, sir?
Thank you, Engineer Anil Kumar Burra. You did a very good job. Shall we take questions? One or two questions? Anil Garu,
Sir,
shall we take questions?
absolutely, absolutely, sir, absolutely, absolutely.
I request participants, please raise your hand, or you may post your questions in the chat box. Speaker Anil Kumar is ready to answer you. Right now, he is working at Germany. I request participants to raise your voice. You may interact with Mr. Anil Kumar. Or you post a message or question in chat box, whichever is convenient for you. If you raise hand, we'll unmute you. Two participants raise hand. Mahanesh, please proceed.
Yeah, good afternoon. Good afternoon, sir. It was a very good session, Anil, sir.
Thank you
My
very much.
question is, you told about the IoTs in the automotive domain. So
Yep.
when we put a IoT in the automotive domain, the cost of the vehicle goes up.
Absolutely.
So what is the strategy what the company is using to optimize the cost of the vehicle?
That actually is an interesting discussion that's going on, because as I mentioned in the presentation, it's not just from one side the information is coming in. The information into the car is from different sources. So one of the most important thing that the OEMs are requesting right now on today's to minimize the scale is to implement on a standard interface platform. If you have a standard interface, then probably the security that can be provided for the host system as well as for multiple sources will be more. So that is, sir. Sorry. So that is one of those interesting things. But actually, OEMs are not putting their foot back on investing any number of resources for dealing with security, because they want to prove that autonomous driving is going to be there, and autonomous driving is only fulfilled if the IoT is more secure. So they are parallelly going with both cost reduction as well as technology upgrades at the same time. Hope this information answered your question.
Sir, now Naveen Kumar, Dr. Naveen Kumar.
Hi, sir.
Please.
Good afternoon.
Please, good afternoon.
Hi, Mr. Engineer Anil. How are you?
Sir, I'm good, sir. Thank you. How are you?
Your explanation is very good and awesome. We're very happy. So very new things we learned through this seminar, and my sincere thanks to our Kamaraju sir and Rajasekhar sir. Here I have only a small doubt. How to reach all these IoT techniques or strategies, how to implement to the villagers and poor needy peoples, how it helps this society?
This is to have, for example, you can help them avoiding accidents, for example, sir. So if in a rural area, for example, I mean, this is a far-fetched example, so to say, but anyways, I'll say it. for a kid who is running onto a road without any notice of any car that is coming, with the help of IoT, with the kind of sensing technologies that that the infrastructure is having on the current day, it actually detects any kind of movement on the street and signals it back to the car. So what essentially happens is either the driver gets the information that there is an obstacle coming up,
Okay.
or the machine actually applies the brake itself. So this is one kind of help that we can provide to minimize the amount of accidents that are going around. But these are very high-end designed in the car, so I'm not sure if how long it would take for a rural area to hit this zone. But slowly, it is always the intention from any kind of OEMs or tier ones to have a secured path overall.
Nice. Thank you, Anil. Thank you very much. Nice lecture. Thank you.
Thank you, sir.
Mr. Anil, another question asking,
Sir.
Dr. Saileja Agnihotri.
Sir.
So please tell some upcoming research topics in this area.
I mean, which area in specific, ma'am? Is it
IoT
with,
area?
Okay. When I'm talking about IoT, I'm talking about IoT in automotive. The very hot discussion in IoT in automotive is to have a cumulative node that operates or that stabilizes all the other nodes in a car, and this node has to be the master for how to say the master node that enables the communication between the other world to the car itself. So in the presentation I was mentioning V2X. So V2X is vehicle to everything. So now every node of the car is getting different information from different sources. What the OEMs are going forward, which is already implemented now, is to have one single node, which is called a master node, that actually tackles all the information from every side. And for this master node, that is way easier to have a security protocol established between this node and the rest of the interface than having the security protocols involved for every single node of it. So that is most of the one of the hard topics that is going on, along with the development in microcontrollers, which actually on the basis of hardware provides more security.
Okay, another question from Gautam Gupta. What is the status of some company building IoT enabled ambulance?
It is already there in existence, sir. It is already there in existence. The ambulance, at least the 112 or 911 in the US or in Germany, for example, they do have IoT built ambulances. So what they are trying to have is the idea of, as I mentioned, if I mentioned an example of you calling a friend to pick you up. For example, if something happened in your car and you need a medical assistance, it actually has a button involved with 112 or 911, which automatically, when you press it, the location of your car, the location of everything will be directly sent to it, and the ambulance will be coming into the picture. And even when you are coming with the ambulance have all the sophisticated technologies that the normal car is being used, like having the better route. Although as precedence will be given for the route of an ambulance, they can choose the better route, and the complete detailed information of where the accident happened or what happened is provided by the one click on the car itself. So the communication between these two is well established, and even the infrastructure, embedded infrastructure in the car, in the ambulance itself, is also there. It might take few days for other countries to reach that because of this traffic restrictions or the population size. But this is one of those very, very required area of expertise that or the need of the hour, so to say.
Another question, sir. Is there any relation between IoT in automotive and vehicular ad hoc networks?
They are working together. So actually, the information vehicle ad hoc network, I actually know very little about it. But the training of the IoT with the AIs, the most information has been collected from ad hoc networks, and the information of ad hoc networks is being processed through AI for the IoT purposes. So in future there will not be any resemblance, but for now they are using both commonly.
One more question we'll take up. Which skill sets is more dominant, software or hardware in future IoT technology?
Both. Most definitely both. You can hardly, I mean, you can do 95% of things with software, but it is only how to say, not a problem finder, it's a problem fixer. So with the software you can just solve 95% of your problems, but only with an effective hardware which is embedded with your software, it is only possible to take us from 95 to 100. So that is the reason why Infineon is investing a lot of revenue on building an intelligent microcontroller for IoT purposes in automotive or any other sector. But there is huge rise in software from SHA or ASE or different hash things. But to solve the security aspect of it, so we have done absolutely everything that we could do with software, but it's turn off for hardware to take us to more secure locations or secure platform.
Okay. I hope no more questions. Thank you, Engineer Anil Kumar Burra, for your wonderful session and more energetic session. Thank you. On behalf of organizing committee, I request you to join for validity session. It will shortly it will begin.
Sure.
Rajshekhar Garu, please proceed.
Yes, sir. Anil sir, thank you so much, sir, for accepting our request and sharing your valuable time and knowledge with all of us, sir. Thank you so much, sir.
Thank you. Pleasure is all mine.
Yes, sir. Dear participants, so next we will be having the validatory function of this entire FDP. So before that, so I request once again, so in the ATAL portal, the ATAL portal, whatever this IoT FDP is there, for that feedback is being placed. So you please go to that ATAL portal with your login ID and give that feedback over there. So that is compulsory for getting your certificate from your site. And I request all the participants to give the feedback which is being placed. The link is being placed in the chat box. So please give the feedback. This feedback is taken by us. So please fill this form in which you will be saying about this particular FDP, the sessions and all those particular things. So please fill this feedback for us also. And meanwhile, so you please take time for some 5 minutes. So after that, we will be starting the validatory function. Thank you.
Oh, by the way, sorry.
Yes, sir.
I was asking a question, and I thought I would discuss with it after the presentation. What is the memory requirement in what everybody thinks about the memory requirement of a car during my presentation? Does anyone have the answer for that, or any suggestions for that?
I don't know, sir, exactly, but
yeah, okay.
The
no,
participants, they have not placed any.
Okay. Yeah.
Okay.
So on a normal day, I would definitely give the answer.
Sure.
For a normal smart car, that smart not in the sense of smart, but a normal day-to-day high sophisticated car, the minimum memory requirement is 2 terabytes now.
Okay.
In a car, yeah.
Okay. Thank you, sir.
Yeah.